what I should have done was giving you the gradient formula. Did your test go well, Nzole? I'm so pleased to hear that. That's great. So hopefully you'll get your results after the weekend and you can tell us what you got. Those are nice messages. Thanks, Ria Betswe, and for the nice big smile, Nolwazi. Hello, Jared. Hello, David. Thank you for joining us. Please get started on the do now. I'm sorry, I should have given you the gradient formula. Has everybody got the gradient formula in their books all written down? Do you want me to go and get one and stick it here? Do you remember what it is? Okay, so just in case, okay, please stick it up. I thought as much. Okay, so gradient looks like this. It is the change in y over the change in x. Okay, so this is it written in red over here. Okay, I'm just drawing a little cloud around it. Okay, has everybody been able to do at least one? If you've done, okay, thanks, David. Even if you just do the pink, it doesn't matter. Okay, Anna. All right, so let's just have a quick look at this and then we can get into today's lesson. If you tried to do the pink question, and I'm guessing, David, that's the one that you would have gone with, what did you end up with as the gradient of your line for the pink one? It's okay, Zayan, no problem. Thanks for joining us. Okay, so Nzole said she got -4. Anybody else get -4 for the pink one? Looks good to me, Nzole. Hang on a second. I think I'm going crazy here. I think I've made a mistake. You're right and I'm wrong. Okay, because 6 minus 2 is not 3, is it? Definitely not. So quite right. -4 is the right answer. Okay. Michal Malepe, you got 4. If you've got 4, then did you say 2 minus 6? So the only other way that you could have written this is you could have said 2 minus 6 over 0 minus negative 1, and then you would have still got negative 4. So you did that. Okay, so in other words, what you had was this. So you went 2 minus 6 is fine. So if you start here, then you have to start here. 0 minus negative 1. Okay, so 2 minus 6 leaves you with negative 4. Over 0 plus 1 is 1. And that's why we would have still ended up with negative 4 as an answer. Hello, Phoebe. Are you feeling a bit better than on Tuesday? All right, so that's how we would have. You ready? Awesome. Okay, good. I'm glad you got it, Mohamalepe. All right, so if you start with the 2, you have to go back at the bottom and start with a 0. If you start with a 6, at the bottom, you've got to start with minus 1. All right, anybody managed to do the purple one? No, nobody managed to do the purple one. Okay, all right, well, then we can leave it there. You got, oh, and Am did. Okay, so you got minus 5 over 6. Okay. Oh, Nazole got minus 1 over 6. Well, I hope I didn't make a mistake on this one. Okay, me too. I also got minus 5 over 6. Okay, so Nazole, which way round did you go? I chose to go 3 minus negative 2 over minus 1 minus 5. Or you could have started with minus 2, and then you would have said minus 2 minus 3. Let me just write that in purple here. So minus 2 minus 3 at the top. So we're starting over here. So I'm going to start here at the bottom. Over 5 minus negative 1. So that's going to leave us with negative 5 over 6. You mixed your X and your Y. Yeah, it's quite a common mistake, Nizoli, but at least now you've made that mistake and you're aware of it. So you probably won't do it again the next time. Okay, well done for trying 2 of them. Is there anybody who managed to do C or D? If not, we can move on. Anyone do C or D? Mohamalepe. Okay, Mohamalepe, you raised your hand. You managed to do, did you do C? Do you want to see the answer? I got no. Do you want to ask a question? No. Okay. All right. That's fine. Not a problem. Okay. So today I wanted us to talk about the equation of a straight line. Now, if you recall, we had spoken about this a little bit in our previous lesson, and I had spoken to you about the equation of a straight line and how gradient ties into that. So here is the equation of a straight line. And in grade 10, working out the equation of a straight line in analytical geometry, it can be asked, but it's generally more of a grade 11 concept. That being said, finding the equation of a straight line is something that we are taught in grade 9, and it's something that we do in functions again in grade 10. And it's a very important concept because we need it not just for functions, for paper 1 functions, but we also need it for analytical geometry. We need it for calculus and metric. We need it for analytical geometry. So to be honest with you, for us spending a little bit of time talking about the equation of a straight line is actually very useful for you, not just in this section, but in other sections as well. So how do you find the equation of a straight line? It's the same thing every single time, right? So that means that we need to know and understand what all these different letters represent. Okay, so that's why this is here. So M, this M over here, that I'm drawing the red circle, well, purple circle around, that's our gradient. Can someone remember, what does the word gradient mean? What does it tell us about the line? What is it a measure?
How steep it is.
How steep it is. Good, David, thank you. Okay, so it is a measure of steepness. Okay, slope, exactly, Nzole. And it can be positive if it slopes up to the right, and it can be negative if it slopes down to the right. So in other words, if a straight line is drawn on a Cartesian plane and it does that, then we would say that the gradient is positive. The gradient is greater than 0. If we've drawn a straight line or diagonal line on a Cartesian plane and it does this, we would say that the gradient is negative. It's smaller than 0. Okay, so here, the reason why it's positive is because I'm moving to the right on the x-axis, which is a positive direction, and I'm moving up on the y-axis, which is a positive direction. Okay, so in terms of change in y over change in x, which is what gradient is, both changes are positive. As far as me standing up over here and us walking all the way down to the bottom of the hill in that direction, all right, we are actually walking down and then to the right. Okay, so our change in y is negative over our change in x, which is positive. So a negative over a positive gives us a negative overall. Can you remember what we had said? The gradient of a line that is parallel to the x-axis. What gradient does that have? Can anyone remember? No one remember? Okay, so lines that are flat are horizontal. The other one, vertical lines have an undefined gradient, Anam. Lines that are horizontal have a gradient of 0. Right, let's just talk about that a little bit because it's actually a very important thing and I'm glad you brought it up. Okay. Do the rest of you know what Anam's talking about where she was talking about a line that is, the gradient is undefined? Does that sort of ring a bell a little bit? Yes. Okay, so on a Cartesian plane, lines can either be horizontal and increasing like that. No, it's not a restriction. It's not a restriction. We're discussing gradient. But shame, let me just tell you what it is I'm trying to say. Okay, so on a Cartesian plane, lines can have a positive gradient, like this one. Or they can have a negative gradient, like this one. Correct, Nzole. Or lines can be, okay, that's supposed to be a straight line, a straight horizontal line. So here the gradient is 0. And lines that are, let me just move it over to the right-hand side, vertical lines. Okay, so it's not a perfectly vertical line, I apologize. Okay, here the gradient is undefined. Okay, so horizontal lines have 0 gradient. Okay, lines that slope up to the right have a positive gradient. Lines that slope down to the right have a negative gradient. And vertical lines have a gradient that is undefined. Now, what does the word undefined mean for us in maths? When we talk about something being undefined, what does it actually mean? Can be any number? Unfortunately not. David, I don't know. Well, in that case, I'm very glad I asked the question. Right, so when something is undefined in mathematics, it means not necessarily infinity, Daniel, but that's a good suggestion. Means there's no meaning, means the number is not real. I like all your suggestions. Okay, so Nolwazi, it's a very common misconception amongst math students that non-real and undefined means the same thing. Okay, so if something is not real, it is actually that's a good one, Rare Betsway. It's means something a little bit different if it's undefined. Okay, so if something is undefined, it means that division by 0 has taken place. Okay, so it's not possible to define a value, okay, because it's not possible for us to divide by 0. So what I mean is this, okay, let's draw a better looking Cartesian plane. Hopefully my lines will be a little bit straighter. So that's an x-axis and that's a y-axis. Here in blue is a vertical line, badly drawn by me, but a vertical line nonetheless. Let's pretend that this point over here, I'm going to call it A. Let's pretend it has the coordinates 1 and 4. And that down here in quadrant 4, we've got point B. It lies in the same vertical line as A. So therefore, it has the same X or Y, has to have the same X. It's going to have a different Y. It's going to have a negative Y value. Let's say it's got a negative Y value of -2. Now, let's pretend we want to come along and we want to work out the gradient of this line. So we'll do what we've always done. We come along, we label, okay, so if we want to make that one x1, we want to make that one y1, we make this one x2, we make this one y2, we write down our formula for gradient, and now we're going to go ahead and we're going to substitute. So y2 in this case is equal to -2, so let's sub that in. y1 is equal to 4. x2 is equal to 1. x1 is also equal to 1. So what we've got here, grade 10s, is -6 in the numerator, and we have 0 in the denominator. Okay, so that's why it's undefined, okay, because division by 0 is taking place. All right, so lines that are vertical have a gradient that is undefined. Lines that are horizontal have a 0 gradient. Lines that slope up to the right have got a positive gradient. Lines that slope down to the right have got a negative gradient. By all accounts, when we say that something is non-real, what we are saying is that it fits onto basically a different number line. There's actually a definition for non-real numbers. So the definition of a number being non-real is actually the square root of -1, and that's defined mathematically as the letter I. If you do AP maths, then you learn more about non-real numbers and calculating with non-real numbers. But non-real and undefined are actually not the same thing, but a lot of people think that they are. Yes, you would just write undefined. Quite right, Phoebe. If there was a question that was asked in a test, you would say that the gradient is undefined. Okay, so we can't calculate the gradient of a vertical line, but we can still work out its length. Okay, so it's still possible for me to know how long AB is. I just can't get an equation in terms of y equals mx plus c for it. Okay, so this line over here, the one that I've drawn for you, that would simply be the line. Anybody know what we would call this line, AB? Does anybody know what its equation would be? Anyone want to make a suggestion? Doesn't matter, even if you're wrong, doesn't matter. It would be y equals undefined. Good job. Okay, linear, it is linear, but this is actually the line x equals 1. Does that make sense? And did you know, incidentally, that the y-axis the y-axis is defined by x equals 0. It doesn't matter, Phoebe. It doesn't matter that you weren't even close. Does that make sense, grade 10s? Incidentally, and I mean, stuff like this is actually really important because you're going to need this for functions for next year. If I was to draw a line over here, and that point over there, let's say that was -3, then this would be the line x equals, oopsie, not -13, just -3 like that. Okay, so lines that are x equals are vertical ones. Lines that are horizontal are y equals. All right, anyway, sorry, I digressed. Let me move back and carry on with what we were talking about. Okay, so we were talking about finding the equation of a straight line. And we were talking about gradient being a measure of steepness. Does anybody know what the C represents? What does this letter C here mean for us? So M is the gradient, C is the y-intercept. Good, Phoebe, well done, the y-intercept. Okay, so in other words, the value at which the graph crosses the y-axis. Yes, Norwazi, the y-intercept. Good job, excellent. And what do the x and y represent? Anybody know what's x and y? Inputs, good, Phoebe. X's are inputs and y are, yes, those are coordinates. So x and y is any coordinate pair of any point that lies on that particular line. Okay, so the x is the number that goes in and the y is the corresponding number that comes out. So generally speaking, if we want to solve for one of the other variables, they will give us a point and then we will sub the x in where x is supposed to go and y in where the y is supposed to go. Okay, so now when they want us to work out the equation of a straight line, they can ask us to do it in a couple of different ways. They could ask us to do it by giving us information like they have done on the left-hand side here, where they say to us, determine the equation of the following line. It is a straight line and it passes through the point -6 and 0 and 2. What information have they given us? So in number 3 here, what information do we have? Correct, Phoebe. They've given us x and y values. So they've given us 2 coordinates, okay? So the x coordinates at one point, x and y coordinates at one point, and the x and y coordinates at another point. When they ask us to find the equation of a straight line, they are saying to us, we want y equals mx plus c. And it's our job to work out the value of the m. And it's also our job to work out the value of the c. So that's what they want from you every single time. They want you to work out the equation of a straight line. They are essentially saying to you, work out the gradient of the line and work out what the y-intercept of the line is. Now, can anybody tell me what is the difference in terms of the kind of information that has been given in the first question? So this pair of coordinates over here, as opposed to what's been given to us over here. What have they given us in the question at the top that they haven't given us in the question at the bottom? Does anyone know? Why do you think I've drawn a red circle around the 0 and the 2? When a pair of coordinates starts with a 0, what are they telling us very specifically about that point? This point has to lie on the, does anyone know? Not because x is undefined. No, there's no undefined gradients here. So this point must lie not in the middle. This point must lie exactly on the y-axis, Nizole. Good guys, on the y-axis. Okay, because x is equal to 0. So this point has to lie on the y-axis. So if they ask you to find the equation of a straight line, and one of the coordinates that they've given you is 0 followed by a number. So in other words, they are specifically telling you the x coordinate is 0, right? What they are really telling you is the value of the y-intercept. So here in this question, we don't need to calculate the 2. We can simply read it from the coordinates that have been given to us. So we know straight away that C is 2. That means the only thing that's left for us to do is to work out what the gradient is. So working out the gradient, we would say change in y, so 2 minus 6 over 0 minus -1. So that would leave us with -4 over 1, which would leave us with -4. You see the difference, Phoebe? So then we could come along and we could quite confidently say, okay, well, the equation of this line, it's the line y equals -4x plus 2. Okay, so you've got to be able to understand the information that has been given. Okay, so here, one of the points that they gave you, why would you want the C value to be equal to 6, Rebetswe?
Ma'am, I'm asking because also the other coordinates that were given, y is equals to 6.
Yes,
So
now, but this is not a point on an axis. It's not a point on the axis. So in other words, where does the point -1 and 6 sit?
Y-axis.
No. The point -1 and 6, the point -1 and 6 will sit somewhere in the second quadrant. Okay, it's not a point on the axis. So in other words, what they've given us is they've given us one point that sits on the, yes, in the second quadrant. They've given us another point that sits over here on the axis. And they've told us to work out the equation of this line. Okay, so it's important to understand the kinds of things that they are telling you in the information that they are giving to you, right? So we don't go further and work out the x. Which x? Oh, I'm glad, Rebets, we're in the equation. No, Phoebe, because what they were asking us for was the equation of the straight line. Okay, if they now want us to work out what its x-intercept is or its y, we know what the y-intercept is, then we can go ahead and sub in. But remember, we were just asked for the equation of the straight line. So it was our job to work out the m and our job to work out the c. Okay, so now contrast that against the second question. Okay, so the number 4, all right? In terms of the kind of information that they have given you, have they told us what the y-intercept is of the line in question 4? Have they told us? Does the information come provided? What do you think, grade 10s? No, quite right, Phoebe, it's not provided. Okay, so that's how we've got to look at this and understand what they're telling us. So in question number four is a little bit more difficult than question number 3. In question number 3, they told us the y-intercept, they told us the value of c, so we only needed to calculate m. Then when we look at question number 4, we can see that the first point lies in quadrant 2, the second point lies in quadrant 4, and neither of those 2 points are a y-intercept. So now we have to calculate m and we have to calculate c, right? So what we do is we calculate m first using gradient formula. Okay, so now I'm going to get you guys to do that bit for me, all right? So in question number 4, I would like you to please calculate the gradient of that line. And when you've got an answer, pop it in the chat for me. Anyone got an answer yet? Just the gradient. You don't have to do the equation of the whole line. I just want the gradient. Phoebe says -5/6. Anybody else get the same answer as Phoebe? I agree, Anam. I agree with Phoebe. She is right. I'm also getting -5/6. Cool, Caravo. Well done. Good job. Okay, so good, Nzole. Well done. All right, so now we're only part of the way there. Goodness, Isa. Nice work. What we've worked out is this. We're supposed to work to calculate the m value and the c value. We've worked out the m. So once we've worked out the m, we're going to substitute it in. We're going to say y equals -5/6x plus c. Now we need to work out what the value of this c is. And we do that by substituting. Grade 10s, whether you substitute in the first point or you substitute in the second point, it does not matter. You will get the same answer for C. So let's pretend you got it. You have a C value, David. What did you get for C?
-5/6.
Yes, that's what you got for M. Okay, and you also got the same answer. Good job. Okay, so now when we want to work out the value of C, it does not matter which pair of coordinates we use, provided they lie on the line. So let's say I decide I want to use the first pair of coordinates. I know that the X is -1 when the Y is 3. So I'm going to substitute 3 in place of the Y. I'm going to put -5/6. In place of the X, I'm going to write -1 plus C. And now what I want to do is I want to work out the value of this term and then take it over to the other side. So in other words, -5/6 times -1 will leave me with +5/6. Now I've got to take that over to the other side. So this 5/6 needs to go over to the other side. So it will become 3 minus 5/6. So that means that C will be equal to what, grade 10s? Someone can pop it in the chat or unmute the mic. Indeed, Phoebe. 13/6. Goodness, Isa, 13/6. So what we've done now, I'm sorry, my writing is all over the place here, grade 10s. Indeed, Nolwazi, good. So the equation of this line, it is the line y equals gradient. The gradient was minus 5 over 6x plus 13 over 6. Okay, so there's the gradient we calculated in front of the x, and there is the y-intercept, in this case a fraction, 13 over 6. How does that feel, grade 10s? Good, I'm glad, Phoebe. Good, David says good, Ria Betswe says good, Anam says good. All right, marvelous. So now I am going to give you guys these questions to try. Number 1 is like number 3. Okay, question number 1 is like question number 3. They've given you a point and they've given you the y-intercept. Question number 5 was like question number 4. They've only given us 2 points. Okay, so let's see if you guys can work out the equations of those 2 lines, number 1 and number 5. Maybe what I must do is just move the working here into the middle of the page. Okay, so you try that, grade 10s. I'm going to give you 5 minutes, and then if you're done, you can just pop something in the chat and let me know. Okay. And of course, if you're stuck or confused, please unmute your mic, and I'm more than happy to help you. Is everybody okay to try this? Even if you get it wrong, David, it doesn't matter. Just try it. Okay, that's half of the thing in maths. We mustn't be afraid to get stuff wrong. If we get it wrong, it doesn't matter. It just means that we've done something incorrectly, and it's an opportunity for us to learn and grow. There's nothing wrong with making mistakes. I mean, look, I make mistakes. I'm pretty sure every single lesson I've taught you, I've made a mistake. I mean, there I was saying 6 minus 2 is 3. We all make mistakes, all of us. So just give it a try. Okay, so you've got 2 pairs of coordinates. One pair of coordinates is at -4 and -1. The other coordinates is at 0 and 3. So just see if you can work out the gradient of line number 1, and then we'll talk about how we'll put it together. Anybody got an answer for the gradient of number 1? Anybody managed to work that out? Is there no one who's been able to work out the gradient of the line in number 1? Okay, so you got the answer as 5. Okay, Phoebe, I'm going to compare my answers to you. So that point is the point 0 and 3, right? So we're going to do our change in y. So -1, -3 at the top. Start at -4 and take away 0. So Phoebe, -1, -3 leaves us with -4. -4 minus 0 is also -4. Whoopsie daisy. Sorry, the pen goes funny sometimes. And -4 divided by -4 is 1. Oh, you mean you put the answer for number 5. Sorry, Phoebe, I misunderstood you. Oh, Nasoli, that's brilliant. Brilliant, brilliant, brilliant. I'm so pleased. Well done. That is excellent. Quite right. You've got it. Excellent. Y equals 1x plus 3, because we knew what the y-intercept was over there. Oh, you've just made my day, Nazole. Thank you so much. That is brilliant. Well done. Very, very nice. Did you also get that right, David? I'm so pleased. Awesome stuff, guys. Okay, so Phoebe, what did you get as your answer for number 5? Will you share it with us? Okay, 3 over 5x plus 14 over 5. Okay, Phoebe, let's work it out. All right, so everybody, we're going to check Phoebe's answer here. So gradient Phoebe, we can say something like 4 minus -1 over 2 minus -3. So 4 minus -1 leaves us with 5. And 2 minus -3 leaves us with 5. So I'm getting a gradient of 1. Am I doing something wrong? 4 minus -1. No. Over 2 minus -3. That's what I'm getting. You missed a negative. Okay. It's all right, Phoebe. Again, it doesn't matter. We all make mistakes. All right. So I'm still getting a gradient of 1. So y equals 1x plus c. Now I'm going to sub in one of these points. Whether I sub in the -1 and the -3 and the -1, or the 2 and the 4, it doesn't matter. If I was you and I could always work with positive coordinates, I would go ahead and do that. It just makes life easier. So I'm going to go subbing in 4 equals 1 times 2 plus c. So 1 times 2 is 2. So the 2 is going to go over to the other side. So it will be 4 minus 2, which is equal to c. So that means that c will be equal to 2. So I get the equation of this line as the line y equals 1x plus 2. Indeed. What do you think now? Grade 10s, does that make a little bit more sense? How's everybody feeling? Thumbs up, thumbs down. Confident, not confident. And I'm happy. All right. Could use more practice. Okay, well, I tell you what, Phoebe, no problem. Instead of me doing the next thing, let me make something up. It might end up with fractions that aren't very nice, but the reality is we have to be able to learn how to cope with fractions that aren't very nice. Let's just move over here. You don't completely understand. Okay, Nosisa, don't stress. Okay, let me just do it in stages, okay, Nosisa? You don't have to do everything all at the same time. Maybe you can tell me what it is that you feel you don't understand exactly. Okay. All right, so there's a line. This point over here is point C. Its coordinates are -2 and 6. This point over here is point D. Its coordinates are 5 and -3. Okay. We are going to work out the equation of line CD using the formula y equals mx plus c. Right? So, Nosisa, the first thing that I want you to do is I want you to use gradient formula, and I want you to work out the gradient of line CD. Okay, we'll just do it in steps. So here's gradient formula. Remember, gradient formula is change in y over change in x. Okay, so Nosisa, sure. We'll come back to that. Nizole, there they are. Whoops, in the middle of the screen. Is that long enough? Shimano, you guys have got to write all this stuff down and you've got to listen to what I'm saying. It's difficult. Can I move the screen back, Nizole? Okay. Okay, so Nosisa and everybody else, start by working out the gradient of the line using gradient formula. Right, and then Nosisa, when you've got an answer for gradient, I'm going to ask you if you can please put it in the chat for me. Okay, so Nosisa says she got -9 over 7. Did anybody else get the same answer as Nosisa? Cool, Phoebe. Anyone else get that answer? Okay, Nosisa, that's perfect. 100% perfect. Okay, so you've come along and you've said, I'm working out the gradient. It's the change in y, so -3 minus 6. I'm starting down at the bottom here. So I'm going to start with 5 minus -2. So that leaves us with -9 over 7. A nasty gradient, I will be honest with you, but 100% perfect. Can you see the gradient is negative, Nosisa? And it makes sense because the line slopes down to the right. Okay, so in other words, what this means is that for every 9 units we go down, we're going to walk 7 units to the right. 9 units down and 7 to the right, and 9 down and 7 to the right. That's what it means. Okay, so you did that 100% perfect. Okay, good job. So now you're going to substitute, Nosisa. You're going to write y equals, your m is -9 over 7, x plus c. Now you're going to take a point. Nosisa, you choose. Okay, grade 10s, it's your choice. Either you can sub in point C or you can sub in point D. Both will work. So Nosisa, pick one. Do you want C or do you want D? Nosisa says D. Okay, perfect. So Nosisa, in place of Y, what must we write? So in place of this Y over here, what are we going to write? Good, -3, lovely. Minus 9 over 7. And in place of the X, what are we going to write, Nosisa? Good. You see, you do understand. Well done. Plus C. We're just working with fractions that are a little bit ugly, but that's okay. We've got a calculator to help us. Not a problem. Okay, so now on your calculator, Nosisa, I want you to tell me what minus 9 over 7 times 5 is.
It's -45 over 7.
Beautiful. Perfect. And then what are you going to do with this horrible fraction minus 45 over 7?
I'll cross the -3 to the other side and make it C is equal to -3.
Exactly. So we plus 45 over 7. Okay, because the -45 over 7 went over to the other side. So that's why we had to change its sign. Okay, and now again, you don't have to be scared because you can ask your calculator to work out the answer. So on your calculator, you're going to say -3 plus 45 over 7. And what do we get as an answer now? What's 24 over 7? Perfect. Yes, Phoebe, there we go. There you go. You've nailed it. Okay, quite right. So Phoebe was quick in putting it all together. She says, we've worked out the C value over here. I need to take that and go and sub it in there. So the equation of this line, it is the line y equals minus 9 over 7x plus 24 over 7. And unfortunately, we need to get used to lines sometimes having equations that are like that, where it's not perfect little integers. It's a pleasure, Nosisa. Okay, sometimes all we need is someone just to guide us through the process. But if you have a look, you actually knew what to do. I think you probably were just scared to go ahead and try it. Okay, good job. Well done, grade 10s. How's everybody feeling now? Feeling a little bit more confident? Is it making a bit more sense? Okay, Karabo, I'm so pleased. Phoebe's feeling good. Karabo's feeling good. Definitely more confident. Now, I'm glad, Riabetswe. I'm glad. Are there any questions that anybody wants to ask me? Is there anything that I've done that didn't make sense or you want me to go over again?
No, ma'am.
Okay, Nolwazi, that's fine. Okay, I'm just giggling at the message that David is sending to me. He said, maths is paradise. I hope the rest of you also feel the same way. Makes sense. Oh, goodness, Ole. Okay, so it's been the end of a good, Nasisa, I'm pleased. It's been the end of a long week. I'm not going to do anything further with you guys today. I think you've more than earned some time off. So I hope you have a wonderful Heritage Day tomorrow, and you get an opportunity to relax and enjoy the weekend. And Tula and I will see you guys again next week on Tuesday. I think we've got 2 more lessons on analytical geometry. And then I think that's us done for the term. Is that right, Tula?
Yes, one lesson, there's going to be one lesson which is parallel and perpendicular lines on Tuesday. Then the one on Thursday is an exam sort of preparation exam.
Yeah.
So, yeah. So I think that's it from us. Actually, that's what I was going to tell them as well. Lee, so
okay. So sorry, Tula.
No, that's perfect. It's perfect. Just very succinct. So yeah, you guys have enjoyed such a long week. I know a lot of you said you were writing this on Thursday today. Actually, a lot of you guys were writing. How were your tests today? Those of you who are still here and you wrote the test, how was your test today? Oh, David is writing on Tuesday.
So Phoebe's finished our exams. Nolwazi will be doing statistics after analytical. Will we be doing statistics after analytical geometry? That's a good question, Nolwazi. We must actually go and have a look. I don't know what's up for next term off the top of my head. Okay, so Nozole said it went well. Anybody get any results that they're happy to share with us?
Yeah, it's always nice getting this positive feedback and seeing you guys do well. That's all we want, really. We want to see you doing well and doing great in school. So this makes us happy. That's great, Phoebe. I'm happy to hear that.
Me too. Well done, Phoebe.
Yeah.
So Cecily says it was okay. I think what helped me more is I learned from the workshop about anxiety. Oh. Yeah, and maths anxiety is a big thing. Oh, yeah. Wow, look at Nolwazi. I went from 40 in term 2 to a 73 this term. Oh my word, that is brilliant. That's like an improvement of 33%. Well done.
Yeah.
Very nice.
Nizole is asking if we'll do financial maths next term.
I don't know. If you want to just hang on 2 seconds, I can actually just double check what the schedule is for next term. Let me just go back.
And remember, you guys will always communicate just beforehand, like the whole schedule, so that you guys know what's going to happen when, and you're always prepared. Okay.
So I know that there's geometry that is planned for next term, and then it says exam preparations and Q&A. So I mean, we can always go back and go and speak to the people at Watobe, but I don't think that there was a plan to do financial maths or statistics. But I think that's something that needs to be communicated probably through the mentors. I don't know. I don't want to stand on anyone's toes here, Tula. I don't want to.
No, definitely, because we obviously want to do work that is relevant to the students.
Yeah,
so
of course.
Makes sense. Yeah.
Yeah. Okay.
So yeah, we'll look at that, Nizole, and just see what we can do, and then give you guys feedback based on what we hear.
Yeah, perfect.
Yeah. Otherwise, you guys enjoy your Heritage Day tomorrow. Enjoy your weekend. We'll see you all on Tuesday. Just one last push for this term as far as our lessons go next week. So make sure you all attend, and so you can round up this term nicely. That's it from me. So enjoy the rest of your evening and your weekend. Goodbye, guys.
Bye, everybody.
Bye.
Have a lovely weekend.